Last 2 weeks, I looked into self-hosting a little bit. Just not so much because of Anthropic's Claude Code nerf, but just because I'd like to be independent when it comes to my tools. Did independent stops at hardware provisioning. I will not have H200s or B200s myself. I will have to rent them in the cloud. So I wanted to write something that makes setting up those GPU pods, as they're sometimes referred to, very easy. So I built something called Pi, which lets me manage that. I'm just going to quickly show you that. So I'm here on DataCrunch, picking up Spot instance, because if this dies and is ripped away from me, I don't care. I'm going with an H200, which can fit the smaller open weights models like Quencoder 3, 30B quite nicely. It can also host GPTOs as 120B. And then for my file trick, I have a shared file system or a network volume, and that's where I share, where I store all the downloaded models. The reason being, when I instantiate a new or deploy a new pod, I don't have to re-download models that I've previously re-downloaded. So all the pods I provision have access to this file share, where all the models that I've downloaded previously live. That makes setting up a new pod really fast. So what I get here is an Ubuntu box with CUDA drivers installed, not quite super recent, but recent enough. And that Ubuntu box is connected to an H200 GPU. This is now deployed to their Finland location, and this takes about a minute or so. And then back here, let me just remove the old one because I just killed one. Oopsie. So, right. Now we just wait until this is up and running. As you can see, the shared file system has been added to this GPU instance or pod instance, whatever you want to call it. And it costs me about 80 cents per hour. Now, if I work like that, if I say I work 8 hours a day, that comes out at €6 a day times 30 days, because everybody's working on a weekend, right? So about €200. In addition to that, I have another 100 or so euros in storage cost for the shared file system with 1 terabyte of available storage. So in total, I would pay somewhere between 300 and 400 euros a month for the privilege of having my own H200 in the cloud. These prices will likely come down, but I would already be happy with this price if I can self-host a capable model. So then the question becomes, are there any capable models? Well, we have seen releases of Qwen 3 Coder, GLM 4.5 and 4.5 Air, GPT OSS, and I think that's pretty much it when it comes to capable models. I mean, there's also Kimi K2. Wait, let me see. Kimi K2 and DeepSeek has its own coding model now as well. Well, it doesn't matter. The problem with these is that you need to have an inference stack. So the engine that's basically loading and running the LLM for you, and there's not a lot of options. There's basically Ollama, which is not my most favorite, VLLM, which is my favorite, and SGLang. Those are the big three. Then there's also NVIDIA's TensorRT, and it's very hard to use, so I'm not trying to do that. I'm going with VLLM as my inference engine. And that's basically what Pi helps me with. So I have this pod now. It's a clean Ubuntu install with not much on it. And Pi helps me set this up. Let's call it H200. Then let's give it the SSH command. And then I also have to tell it where the mount is for the shared file system that hosts all the previously downloaded models. Okay. They keep handing me a pod with the same IP address, but the keys change. So I just have to quickly modify my known hosts. God damn it, where's my code? There's my code. Let's kill all of these. This is a live demo, so you get to see all the nitty-gritty parts. Okay, so what this does is it basically sets up this plain Ubuntu box. It installs CUDA toolkit, so the compiler for CUDA code. It installs Torch and VLLM in various versions. So GPT OSS requires its own custom VLLM fork. It's not really a fork. Let's see. GPT OSS. They have a cookbook here, but it's not what I want. I want the real one. So funnily enough, to run this with VLLM, you can't use the release version of VLLM. You can also not use the nightly version. You need to get a special wheel, which is called 0.10.1 plus GPT OSS. And that can basically only run GPT OSS. Well, that's not nice. Other models like GLM require nightly build of VLLM because there's tool parsers and other shit in there that's not yet in mainline or that's not yet in the release version. So that all sucks, but Pi helps me deal with that in that I can in my setup command. Where is it? Hello. Yeah. So I could specify the VLLM version here as well, which is release, a specific commit to get a nightly wheel, or GPT OSS. And that's it. And that covers pretty much all the bases. I can run all the models, all the big models like that. This also works with multi-GPU setups. We'll see later. No, actually we won't. I won't be loading a multi-GPU model because this takes too much time for a video. Anyways, this has been running for a minute now. It usually takes 1 to 2 minutes for this setup process to work. And the end result of that is that locally I have a JSON file that yeah, we are pretty much done here. Locally I have a JSON file now that knows about all my pods. Let's see. And it tells me I have these pods. I have an H200 with this SSH command with these GPUs. These models are deployed currently, none. And here's where the models are stored and which VLLM release I have. And I also have the concept of an active pod. So any subsequent commands I pipe through Pi go to that pod. I can have multiple pods and I can deploy multiple models to a single pod if the GPU has enough resources. So let's see what we can deploy to this one. Pi comes with a list of models you likely want to run, and it can tell you based on the GPU configuration of the pod which one will run on this one. So we could fire up GLM 4.5 Air in both the non-quantized and the quantized version. We could get GPT OSS 120B and 20B going, but honestly we don't have time for that, so we're gonna go with Quencoder 30B, which sounds hilarious, but it's actually a pretty good model, I have to say. Let's call it Quen locally. That's how we refer to it later. Okay, and this is what's happening now. It would have downloaded the Quencoder safe tensors from Hugging Face, but I've already downloaded that once to the shared file system earlier, so it doesn't have to do this anymore. This is usually what takes the longest time when setting up, deploying a model to a pod. And then it just starts VLLM with parameters specific to that model. And this is also something I have made a list of known good parameters, so to speak. And that makes things very easy for me. For example, here the tool call parser needs to be specified and stuff like that. And then if everything goes well, it starts loading the safe tensors from the shared volume and sets up our LLM on that pod. The first time you do this on a freshly instantiated pod, this will take some time, probably due to file caches needing warm up and so on. If you kill that LLM and redeploy it on the same pod, it will be lots faster. I haven't figured out yet if I can also kind of pre-process that or share the results of this initial load with subsequent pod instantiations and VLLM instantiations. Anyways, the end result will be that we will have a nice IP address with a port, which we can query with the OpenAI API. And for that, I have built my own little coding agent called Pi Agent. And the point of this is to be minimal and hackable. So I want people to be able to provide their own system prompts and their own tools very, very easily. This is also actually a very close clone of Claude Code's behavior. This is a work in progress, obviously, but it does the things I need to start testing and figuring out how I want this to work. So currently it has 3 tools: ls for listing directories, read file for reading an entire file into the context, no offsets, and bash, because I like to live dangerously. This tool also has only one mode, which is YOLO. I honestly, I understand that in some environments you want to have extra safeguards. I haven't found this to be a problem ever. And also Claude usually manages to work around that anyways. I just had a case like that today, where it used, instead of doing something like file, it can't access, it actually did ls llh which file. And the Haiku model that they ask to evaluate this command couldn't figure it out, that this is basically an escape hatch to do whatever the fuck you want. So yeah, I YOLO only, and I think you should too. So we're at 50% for the 30B model. This is a BF16 quant, if you want. So it takes about 60 gigabytes of VRAM just for the weights, and then whatever's left is being given to the KV cache, which is the thing responsible for giving you all that nice context window size. In this case, I think it's 250K. Yeah, the max model len is about 226,000 tokens. And it's a pretty interesting experience. So PyAgent, as I said, basic loop system prompt is empty at the moment. Why? Because I want to test the default behavior of models. And that's where I think all of these open source CLIs fall flat. They hide all of that from you. They don't want you to see the system prompt. They don't want you to modify the tools. Maybe you can add MCPs, then you can't abort them, stuff like that. So yeah, if I want to evaluate whether an open weights model is equivalent to a closed weights model, I need the same harness or same scaffold around that in an agentic tool kind of sense. So this is why I built PyAgent, because it's bare bones and it allows me to exactly see what's happening. And eventually, in a couple of nights, it will allow you to plug in any kind of system prompt and any kind of tool kit. So a set of tools that the LLM can use, making this hopefully a versatile tool for building agentic coding tools. It also has an SDK, which looks like this. So let's see. Yeah, it has a JSON mode, just like Claude Code, except this one is bidirectional, which also works with Claude Code, by the way. They just don't document it. You can build a TUI on top of Claude Code in the JSON mode. Anyway, so this is what this does. So you can run the agent and give it some input and say, please use JSON mode, and then you get all kinds of events that you can parse to write a GUI or to write tests, automated tests, evaluations, and so on and so forth. There's also an interactive mode. In that mode, you can send JSON inputs, message and interrupt, to the agent, and it will write out whatever it has to write out on standard out, and keep listening for new messages in JSON, in this JSON format on standard in. So with this, you can build anything, basically. And as I said, the agent can use any kind of model that talks OpenAI. So Croc, no problem. OpenRouter, no problem. We can actually just quickly try that out while the 30B model gets deployed. Let's kill this. Let's go. Hey, and it's really fast. It's very nice. Yeah, this is usable. This is GPT OSS 120B. No idea what distill they use. They probably use it distill because they have custom hardware. And the same works with Anthropic as well, because they also have an endpoint that's OpenAI compatible. I'm not going to fuck around with individual APIs for this, at least not for now. Maybe I'm going to add Anthropic itself. But yeah, I'm happy with OpenAI for evaluation. As you can see, this takes a little bit longer, but this is also Opus 4.1. Yeah. So I can use this to run with any kind of model in the cloud. I can use this to run with my model that's now being deployed to my H200 in the cloud. So let's try this as well. Agent Quen. This is just a shortcut. So I don't have to provide the base URL, the API key, and the model name and all of that shit. So this is nice. List all files. And you will see how quick this is. I can also look at the logs of VLLM while we work on this. So yeah, this is pretty nice. This is a nice setup, and it's reasonably fast for 30B. For the 380B Quen 3 coder, I don't have a lot of experience yet. I've deployed it a couple of times and it works, but I didn't evaluate it in any kind of way. Because I think the problem was that I only got 15 tokens per second output, and that's not fast enough for my taste. All right, so that's the basic setup. Pi to manage your GPU pods, and Pi agent to talk with any LLM, be it the self-hosted one or something that's beefy and closed source, providing you with an equal playground for all of them. No system prompt, or you can specify the system prompt, and a minimal set of tools that you have full access to and that you will be able to completely replace with whatever you want. The replacement mechanism is something I'm working on at the moment. MCP is obviously a choice, but I would like it to work something like this. You just say my tool, and then you have, or wait, something like, I should probably not write in here, but let's try anyways. Name my tool, and then you have your classic args where you define what inputs, what the JSON structure is that your tool expects, and then you have a run, and that could be just an npx, tsx, my tool, tool.ts, for example. If you want to go super bare bones, the alternative would be to just run the MCP, say this is an MCP server, or you write this with Go, I don't care. And eventually you will have a set of these tools which make up a toolkit, and you can just provide that toolkit name to Pi agent on startup, so it gets just the tools that you want and that you might have written yourself, or that you picked off of some MCP server list, whatever you want. Okay, so final point. This is a work in progress, but you can already look at it and play around with it on PyMono. I'm gonna link to this in the description. Not that anyone's gonna see this, but so yeah, this should be well enough documented for you as a human to figure out and for an LLM to figure out. But the last thing I want to show you is a comparison between those things, because that's actually what we are here for, right? My goal is to find a model that's on par with at least Sonnet, for example, in terms of agentic abilities. And agentic abilities aren't just coding. This might also be code search, navigation. This might be something entirely unrelated, like emails, using a Gmail MCP server, for example. And eventually want to set up tests for that. And that's also why I have this little JSON SDK. There's some brainstorming at the bottom. Oh yeah, this is what you need to build your own TUI on top of this. So it's very small. Yeah, I have ideas for testing, evaluating different models against known tasks. This is just a brain dump, really. This isn't fleshed out yet, but the basic gist is you can either go with the UI mode, the TUI mode, and parse that, or you go with the JSON mode, either in interactive mode or in non-interactive mode, and parse the JSON outputs of the model, which includes usage, turns, everything, basically. And then you can use an LLM as a judge to compare the outputs of different LLMs for the same task. And I'm not a big fan of LLM as a judge, but it gives you, it's a good first sniff test. And if your task has a known success criteria, then an LLM is probably one option to evaluate the outputs of a model in this agentic loop against this task success criteria. So yeah, anyways, that's the goal. And the end result should be something that's usable, something that's extendable and tackable, and something that I myself can use to replace Claude Code or Cursor, whatever. So final demo for the day. Let's run PyAgent with GPT-5. And then let's run Anthropic as well. I have this in the help output, so it's quick. Let's make this like this. And then we also have PyAgent Qwen, the one that I'm self-hosting. And they're all in the PyMono repo, which is just this basically, and packages. So my TUI framework, which sucks, my agent, which is built on top of the TUI framework, which is this basic loop here, and the pods thing that I showed you earlier to set up pods. All right, so let's ask them the same thing and see how they do. The task here is code navigation and agentic search. And the test criteria would be how long does it take them to do this? How many turns do they take? How many tool calls do they make? How many tokens do they use? Combined with pricing, this also gives me a good indication of how well off I would be with a self-hosted model. So 300 to 400 euros for this one. Could also host GPT OSS 120B. But the problem with that is that the inference engines like VLLM, Olama, and so on don't really quite work with that because of the stupid new Harmony format that they use. Anyways, so what can I do with this project? And this is something we're going to ask all of the LLMs at once, and then we can see how fast they are. So let's see. Bam, bam, bam. And Qwen jumps ahead. Here we can see the raw input tokens, output tokens, and the number of tool calls made so far. And this alone already gives me a good indication of where everything's headed. So GPT-5 is pressing ahead with a lot of tokens. Oh yeah, Qwen is already done. Let's evaluate Qwen's output real quick. This monolithic collection of tools for matching LLM deployments and building AI agents. Exactly. Here's what you can do with this. Py is the CLI for managing pods. PyAgent, general purpose agent with tool calling and session persistence. Oh yeah, I have full session persistence, just like Cloud Code. So you can resume and continue. Terminal UI, library, perfect. Capabilities, you can blah, blah, blah. Yeah, this looks good. A quick start. This is also very nice. And the project is designed for the developers who want to deploy. Exactly, this is a good summary. So let's see what Anthropic did. A little bit more birdie. How many tools did it call? 8 tools, 6 tools, 6 tools. Interesting. Actually, let me close this down here. So, based on my exploration, this is a monorepo containing powerful package. Yes, very powerful. The most powerful, obviously. Okay, yeah, it gets all of this right. It's a little bit more wordy than this. And it also mentions the pod management in a bit more detail, which is nice. Create terminals, yeah, primary use cases on platform, blah, blah, blah. Development commands, yeah, this looks good. And then we have GPT-5. It actually did pretty well. It just sucks at outputting nicely formatted Markdown for some reason. Monorepo, chat agent. Well, it's not a chat agent, but I'll let that pass. GPU pod manager, self-hosted models. Yep. Common dev tasks. This is straight from the README in the root directory. Yeah, looks fine. So let's see what tools they called actually. So this did listed the root directory, read the root README, listed the packages, and then the agent, the pods, and the TUI README. And this is exactly what I'd expect. And it did that, and it summarized what it saw. Now Qwen did the TUI, the agent, and the pods README, listed the packages, read the README in the root. It is exactly the same. So same amount of tool calls, exact order, I think. Same input into the context window. Very close in terms of inputs. Not so close in terms of outputs. And tool calls are the same. And Anthropic did what? Pods, agent, TUI, Claude MD, for whatever reason. Packages list, packages JSON, I guess, to get all the build commands, which are already listed in the README. So it did a little bit more work. But yeah, they all ended up pretty much where you'd expect them to end up, except that Claude did a little bit more. Now, this is not a formal evaluation, but it gives you a good idea of where each of these are for this one specific task. And tasks like that need to be more complex. And that's what I'm trying to work on in the future, to make it easy to define these kinds of tasks and then have them evaluated across multiple LLMs and providers using Pi and Pi Agent. And that's what I'm doing.